Assalamualaikum. Bismillahirrahmanirrahim. Assalamualaikum to all my beloved students outside there, as well as the parents that join my class for this evening. I'm Cikgu FATHIAH from Pusat Tingkatan 6 SMK Seri Serdang, Selangor. Now I sharing my lesson from the video that I have been recorded under the topic Oxygen Dissociation Curve. We are now on my channel Cikgu FATHIAH66. Yeah, for those that not subscribe, please subscribe for the notification to get the new videos. Before we start our lesson, let we recite Al-Fatihah. Al-Fatihah, Bismillahirrahmanirrahim. First of all, thank you very much to all the viewers outside there for joining my class. Okay, so let we start our lesson. Okay, for this tuition, biology tuition for this evening, we will discuss about the oxygen dissociation curve. So before we get the idea or the concept of the oxygen dissociation curve, let we check the learning outcome for this topic, oxygen dissociation curve for STPM. And also for matriculation student, for STPM student. Number 1, explain oxygen dissociation curve for hemoglobin, myoglobin, and fetal hemoglobin. And then number 2, explain the Bohr effect and relate it to oxygen dissociation curve. For matriculation, learning outcome, analyze oxygen dissociation curve of the hemoglobin. Number 2, compare oxygen dissociation curve of myoglobin and hemoglobin. Number 3, analyze the effect of changes in the partial pressure of carbon dioxide toward the oxygen dissociation curve or Bohr effect. Okay, before we get the idea what is the oxygen dissociation curve. Actually, it is the words is came from the oxygen dissociation and curve. So let we check or we revise back your knowledge, student. In our body, oxygen is transported throughout our body, in the red blood cell. So what is the element that will carry the oxygen in our body is we call as hemoglobin molecule. Hemoglobin molecules. Oxygen, beside it is transported in the red blood cell by hemoglobin. Oxygen also dissolve directly in the blood stream. Okay. Okay, hemoglobin. What is hemoglobin? Hemoglobin is the primary vehicle for transporting oxygen in the blood. So hemoglobin almost carry oxygen 98% in the blood. So approximately 167 milliliter oxygen carry by 1 liter. So this is the structure of hemoglobin. So for this topic, oxygen dissociation curve actually came from the word dissociate. Dissociate. Before we learn about the dissociate, actually, the word is from associate. Beside the dissociate, dissociation of oxyhemoglobin actually, to form back hemoglobin and oxygen. Association. Let me check the what we call the slide. Okay, association meaning hemoglobin combined with oxygen. Oxygen associate with hemoglobin. to form oxyhemoglobin. Where is the location? In the alveoli of the lung, where when it has high partial pressure of oxygen. When the condition high partial pressure of oxygen, location in the lung, oxygen will associate with the hemoglobin to form oxyhemoglobin. Whereas in the condition where the partial pressure of oxygen is very low, where is the site or the location is in the tissue, oxyhemoglobin will dissociate to form back the hemoglobin and oxygen. Okay. Teacher, saya check dulu ya. Okay, the slide is okay. Okay. So hemoglobin has the capacity to carry 4 molecule oxygen because it has 4 hem group. Molecule oxygen actually bind to the ion or hem of the hem prostatic group. So hemoglobin has 4 hem group, so it can carry 4 molecule oxygen. Let me check the slide. Okay. Okay, the binding first molecule oxygen to the hemoglobin. Okay, this what we call hemoglobin, no binding of molecule oxygen. And then when one molecule oxygen bind, it will induce changes in the shape of hemoglobin. So what is the implication? Hemoglobin will increase its ability to bind to the other 3 molecule. One molecule oxygen bind, it alter conformation of the hemoglobin, making subsequent binding easier. Or what we call the term, we call as cooperative binding. Cooperative binding meaning one molecule oxygen bind, alter the conformation of the hemoglobin, so making the hemoglobin easier to bind to either oxygen number 2, number 3 and number 4. Cooperative binding. Cikgu check dulu slide. Okay. Okay, now we go to the concept that we will learn today. Oxygen dissociation curve. Or we call as oxyhemoglobin dissociation curve is the same. So it describes relationship between the partial pressure of oxygen at the x-axis. X-axis is the partial pressure of oxygen. Let me check. Okay. Graph is bigger size. For the x-axis, for the partial pressure of the what we call the oxygen dissociation curve, it has x-axis, the partial pressure of oxygen, unit, millimeter mercury. And then for the y-axis is oxygen saturation of hemoglobin, or hemoglobin saturation of oxygen, unit is percentage. So at the x-axis, you can see or observe here, when the partial pressure of oxygen is increases, where is the location? In the lung. It will reach 100 millimeter mercury. And then you check here, at the tissue, when the oxygen blood travel to the tissue. So here partial pressure of oxygen is decreases, is low, 40 millimeter mercury. And then you can check, you can observe here, the graph, from 0 partial pressure of oxygen, when we increases the partial pressure of oxygen, so the saturation of hemoglobin percentage, saturation of oxygen of hemoglobin will increases until reach to the highest partial pressure of oxygen, 100 millimeter mercury. So what is the saturation here? 95%, yeah. Actually, it not reach 100% in the real situation, yeah. 95%. At this value of the partial pressure of oxygen, 40 millimeter mercury, the saturation of hemoglobin to oxygen is just 78%. Yeah. Okay. Check again the slide just now. Yeah. Oxygen dissociation curve show the relationship between the degree of hemoglobin saturation with oxygen at different values of partial pressure of oxygen. Yeah. So y-axis, yeah, show degree of hemoglobin saturation with oxygen at the different value of partial pressure of oxygen. Yeah, for this graph. Okay, oxygen dissociation curve show the affinity of hemoglobin for oxygen. Yeah, it show how readily hemoglobin acquire oxygen molecule and how hemoglobin release oxygen molecule into the fluid that surround it. Yeah. Okay, if you check this, okay, graph, at this area, at 60 partial pressure of oxygen, check, after here lah, it will increase until 60 millimeter mercury, partial pressure of oxygen. So this area, the when we add increase partial pressure, so percentage of saturation, it is low, what we call association of oxygen, in the hemoglobin is slow, compared, and then if you check here at this area, this one is this loading, this one is loading area. Loading meaning oxygen will combine or associate with hemoglobin. This area, the steepness area, is uploading area. Uploading area meaning oxyhemoglobin will dissociate to form back hemoglobin and oxygen, because at this area, at the tissue need more oxygen, so oxygen will what we call release to the tissue. Okay, the curve is important tool for understanding how our blood carries and release oxygen. Okay, from this diagram, you can know or you can learn that at the partial pressure of oxygen is high, so the oxygen will associate with hemoglobin. Affinity to hemoglobin is very high, and then at the partial pressure of oxygen, what we call decreases, so oxyhemoglobin will dissociate to form oxygen and hemoglobin. Okay, the curve is sigmoid shape. Okay, if you observe, this what we call graph, the shape of this curve is sigmoid. It is not a linear. If linear, when we increases, so it will tend to increases, no limit. But at this shape, the shape is sigmoid because at this area, the what we call when we increases of pressure of oxygen, so it is very slow, combination or association of oxygen or what we call saturation oxygen in hemoglobin, percentage is very slow until this area, so at this part is low, what we call saturation is low, and then when added the partial pressure of oxygen, so percentage of saturation will increases. Okay. Curve is sigmoid shape due to the cooperative of hemoglobin in binding with oxygen. Just now we learned that cooperative binding meaning when one molecule oxygen bind, it will change the conformation of hemoglobin and tend to increases the what we call binding to other three molecule of oxygen. The binding of the first molecule is difficult. However, this facilitates the binding of the second, third, and fourth. This is due to the induced conformation of change in the structure of the hemoglobin molecule induced by the binding of oxygen molecule. Okay. Okay. For each, let me check the slide. Okay. For each oxygen molecule bind, it will alter conformation of hemoglobin, making subsequent binding easier. So we call it, the term is cooperative binding. It means hemoglobin will have a higher affinity of oxygen in oxygen-rich area, like lung, promoting the oxygen loading. Just now, teacher or cikgu dah mention. So in the graph of oxygen dissociation curve, there are part we call loading area and unloading area. Loading area, why? The hemoglobin will have higher affinity of oxygen in rich area, like lung and the arteries lah. Okay, the area unloading. Okay, we check here. The graph. Okay, this is loading area. Loading area when the hemoglobin has the affinity toward oxygen is very high. When the partial pressure of oxygen is high. Uploading area. Uploading area meaning affinity hemoglobin to oxygen is low when at the condition partial pressure of oxygen is low, or decreases lah, low. Okay, hemoglobin affinity for oxygen increases as successive molecule of oxygen bind. More molecule bind as the oxygen partial pressure increase until the maximum amount that can be bound each reach. Meaning, at the plateau area, when we increase the oxygen partial pressure of oxygen, so it will not increases, remain. As the limit is approached, very little addition of binding occur, and the curve level out of the hemoglobin becomes saturated with oxygen. Teacher check. Okay. Okay. When we increases, so it will, we added after 85 value partial pressure of oxygen. So increases, so it remain the same. So plateau area. Okay, in the lung, at the alveoli capillary interface, the partial pressure of oxygen is typically high, and therefore the oxygen bind readily to hemoglobin that is present. As the blood circulates to other body tissue, in which the partial pressure of oxygen is less, the hemoglobin releases the oxygen into the tissue. So at the alveoli capillary interface, the hemoglobin has affinity to oxygen is very high. Compare when the blood circulate to other body. So at this area, hemoglobin release oxygen. Affinity hemoglobin to oxygen is low. Okay, plateau portion of the oxyhemoglobin dissociate curve is the range exists at the pulmonary capillary. So minimum reduction of oxygen transported until the partial pressure fall. 50 millimeter mercury. The steep portion, okay, this steep portion, this area, steep portion of the oxyhemoglobin dissociation curve is the range that exists at the systemic capillary. A small drop of systemic capillary partial pressure of oxygen can result in the release of the large amounts of oxygen for the metabolically active cell. Okay. Okay, I will show you another. Okay, this another graph that more what we call clear. Yeah. So here at the loading tension, yeah, the word is loading, uploading. Yeah, loading tension meaning oxygen will associate with hemoglobin, yeah, to form hemoglobin. So at this area, yeah, affinity hemoglobin to oxygen is very high. Yeah. So at the loading area, at the loading tension, hemoglobin is about 95%. Yeah. Here 95%. Yeah. Cannot reach 100. Even we increases the partial pressure of oxygen, same. It is remain. Yeah. Remain almost saturated. Why? Because almost all the hemoglobin is saturated with oxygen. Yeah. Okay, where is the location? Lung, pulmonary vein, and systemic arteries. Yeah. Okay, for the steepness area, this area is uploading. Yeah? Uploading meaning oxyhemoglobin will dissociate back to form hemoglobin and oxygen. Why? This area is when the what we call the blood, yeah, flow, flow to the next to the cell. So location dia ialah blood in the systemic capillary. Yeah. So what happened here? Uploading tension, oxyhemoglobin will release or dissociate to form hemoglobin and oxygen. So oxygen will diffuse or transported to the cell, yeah, that need oxygen, yeah, undergo the respiring tissue, respiration, yeah, aerobic respiration. A small decrease of partial pressure, yeah, small decrease here. Okay, let me check. Here is 5 to 4, small decrease in percentage of oxygen saturation of hemoglobin. Oxygen is released by hemoglobin for respiring tissue. Let me check. Okay. Okay, at pressure about above 60 millimeter mercury, dissociation curve is relatively flat. Okay, check. Above 60, actually it is a small increases of the association of oxygen with hemoglobin. Saturation slow lah. So, meaning the increases of the percentage saturation is not much. Which mean that the oxygen content of blood does not change significantly even the large of increases in the oxygen partial pressure. The flat upper plateau decreases variability in the blood oxygen content, even the large changes of the partial pressure of oxygen. Okay, how about the steep lower? Steep lower part allow the increased release of oxygen from the hemoglobin with only a small change in partial pressure. If you check here, below the steepness, okay, partial pressure is very low, there is almost complete dissociation, near to zero, of hemoglobin to release oxygen to respiring tissue. Okay, so S shape for the oxygen dissociation curve show here, meaning at the partial pressure of oxygen is very high at the lung, affinity hemoglobin to oxygen is very high. So it tend to what we call combine with oxygen. At the respiring tissue, at the partial pressure of oxygen is low, near to the tissue. At the rest, you can see 40, so value percentage of hemoglobin saturation with oxygen, 78. At high partial pressure of oxygen, okay, we check here 100. So value dia 95%. Okay, active cell tissue or active tissue at 20, saturation of hemoglobin is value dia is below 20%. So at this area, oxyhemoglobin tend to dissociate. And then at this area, affinity hemoglobin to oxygen is low. We check the, okay. Okay, now we go to second part. We have here another type of hemoglobin, fetal hemoglobin. How about the oxygen dissociation curve of fetal hemoglobin? So hemoglobin of the fetus has a slightly different molecule composition to adult hemoglobin. If you see here, fetal hemoglobin have 2 alpha and 2 gamma unit. Whereas for the maternal or adult hemoglobin has 2 beta and 2 alpha. So the different different structure will give implication to the oxygen dissociation curve between the fetal and mother. Fetal hemoglobin or fetal hemoglobin is the main oxygen carrier protein in the human fetus. Hemoglobin fetus is found in the fetal red blood cell and it is involved in transporting oxygen from the mother's blood stream to the organ and tissue in the fetus. It is produced at around 6 weeks of pregnancy and the level remain high after birth until the baby is roughly 2 to 4 months old. Okay. The fetal dissociation curve is shift to the left. If you check here. Fetal hemoglobin compared to mother adult or maternal hemoglobin, fetal hemoglobin is shift to the left. Mother hemoglobin lies at the right. Okay, relatively to the curve of the normal, because of the feature, hemoglobin fetal bind more strongly to oxygen, because it have gamma subunit. If the oxygen dissociation curve lies to the left, meaning it binds strongly, or we call it has affinity to oxygen is higher compared to the curve that lies to the right. Okay, why? Fetal hemoglobin lie to the have higher affinity toward oxygen compared to the maternal, because it has what we call alpha subunit. Alpha subunit, it has affinity toward oxygen is higher than the beta subunit. It is important as it means fetal hemoglobin will load oxygen when adult hemoglobin or mother hemoglobin is unloading. Following birth, fetal hemoglobin is almost completely replaced by adult hemoglobin almost 6 months. After postnatal, after birth, 6 months, the baby will what we call get or form the adult hemoglobin. Okay, higher affinity of fetal hemoglobin for oxygen compared to adult have implication. Number 1, oxygen dissociation curve is shift to the left. That means fetal hemoglobin can easily saturated with oxygen at the even lower partial pressure of oxygen. Saturated. Okay, we check the graph here. At lower, we compare adult hemoglobin to fetal. Let me check the diagram. Okay. Lower, what we call partial pressure of oxygen. Fetal hemoglobin, value dia 90 something percentage of saturation. Whereas for the mother, just 78. So fetal hemoglobin can what we call loading oxygen at lower partial pressure of oxygen compared to the mother. Easily saturated with oxygen at even lower partial pressure of oxygen. The high affinity of fetal hemoglobin for oxygen ensures sufficient and efficient oxygen supply to the fetus. High affinity. Why? Because lie to the left. Okay. Okay, now we go to what we call third part. Type 2. hemoglobin. So this one we call as myoglobin. What is the myoglobin? Myoglobin is an oxygen binding molecule that is found in the skeletal muscle. So myoglobin can found in it is hemoglobin that in the muscle tissue. Myoglobin is a conjugated protein consisting of globin protein and a hem group. It thus having chemical properties similar to the hemoglobin. It is the same, conjugated protein also has a hem group, but the difference is it is made out of single polypeptide, with only one hem group. So it doesn't have cooperative binding because it just one hem group. Okay. This is the what we call the structure of myoglobin. It has one polypeptide and one hem group. What is the effect? Okay. Myoglobin dissociation curve is hyperbolic in shape. Hyperbolic. It not show the sigmoid shape. Hyperbolic meaning at this low partial pressure, it can bind. With oxygen. Percentage of saturation is very high. Compare to the adult hemoglobin. Okay, myoglobin. Hyperbolic shape and occur the left of the hemoglobin dissociation curve. Left meaning affinity toward oxygen is higher compared to the adult hemoglobin. Okay. Myoglobin bind very strongly with oxygen to form oxyhemoglobin, which is more stable than oxyhemoglobin. So it can bind strongly with the oxygen bind with the oxyhemoglobin, myoglobin to form oxyhemoglobin. Stable than oxyhemoglobin. Oxymyoglobin. Myoglobin binds very strongly with oxygen to form oxymyoglobin, which is more stable than oxyhemoglobin. Myoglobin act as oxygen store in the muscle that will only dissociate when the partial pressure of the oxygen is very low. So you can let me check. Okay. Stiffness here just just now we learn about the loading and uploading. Loading area when the oxygen associate with the hemoglobin. What we call uploading area. This is the stiffness. Stiffness meaning at this area, the oxymyoglobin. Oxymyoglobin will dissociate to form oxygen and myoglobin. So what is the value for the partial pressure here? You can observe here. The value is less than 20. So it will dissociate. Compared to the hemoglobin. Hemoglobin stiffness here. 40 lah. 40. Alright, 40. It is when our blood is transported near to the cell kan. So this one after more than 20. So the stiffness is here uploading. Uploading meaning dissociate lah. The oxyhemoglobin dissociate. Okay, myoglobin has higher affinity for oxygen than adult hemoglobin and becomes saturated at lower oxygen level. Myoglobin will hold onto its oxygen supply until level in muscle are very low. The delay release of oxygen help to slow the onset of anaerobic respiration and lactic acid formation during exercise. Okay, this difference is due to the following reason. Why myoglobin? The shape is hyperbolic. And it is shift to the left, meaning it has higher affinity to oxygen. Why? Because Each myoglobin molecule has only one hem group that attach to only one globin. Yeah. So in contrast, hemoglobin has 4 hem group that attach to the 4 different globin in the same molecule. Yeah. When oxygen molecule dissociate from one oxyhemoglobin molecule, changes in the oxyhemoglobin molecule make it easier for the remaining oxygen molecule to dissociate as well. Yeah. This way explain why at moderate oxygen partial pressure, oxyhemoglobin releases oxygen while oxymyoglobin still bind oxygen molecule. Yeah. So you check here. For the check this. Okay. For the hemoglobin, it is easily to dissociate because when one dissociate, another the second, third, and fourth molecule will also easily to dissociate. But it is not happen to the myoglobin because it has just one hem group. So it is very difficult to dissociate until it reach very low partial pressure of oxygen below 20. So it will dissociate. Okay. Okay, now we go to the last part in our what we call sharing. Yeah. Okay, Bohr shift or Bohr effect. Yeah. Bohr effect. Okay. So when you observe a graph, that in the graph has graph that oxygen that show the oxygen dissociation curve. Yeah. That have different partial pressure of carbon dioxide or what we call the concentration of carbon dioxide. The first graph here, it has 7.45 partial pressure of carbon dioxide. Second graph, 7.35. So which one has the highest carbon dioxide? So this one has higher carbon dioxide. So the what we call the pH level, pH value will decreases. So the what we call the oxygen dissociation curve will shift to the right. Yeah. So we call as the Bohr effect. So how it can happen? When the partial pressure of carbon dioxide in the blood increases, the affinity of hemoglobin for oxygen decreases. Yeah. So carbon dioxide lower the pH of the blood by forming carbonic acid, which causes the hemoglobin to release its oxygen. Yeah. A decrease of pH shift oxygen dissociation curve to the right. Yeah. So if you check here, oxygen dissociation curve shift to the right, meaning at 7.35 what we call the pH. pH is low, meaning affinity hemoglobin to oxygen is decreases. So it tend to uploading, dissociate to form oxygen and oxygen and hemoglobin. The Bohr effect facilitates oxygen transport as it causes hemoglobin to bind to oxygen in the lungs but release it in the tissue. And this is the advantage of Bohr effect. Particularly, those tissue is most need of oxygen. When a tissue metabolic rate increases, its carbon dioxide production increases. Okay, when the tissue metabolic rate is increased, carbon dioxide production also increase. Carbon dioxide form bicarbonate ions and hydrogen ion through the following reaction. Carbon dioxide will enter the blood, it will combine to the plasma that have water. So it will form carbonic acid, and then carbonic acid will dissociate, become hydrogen ion and bicarbonate ion. So the hydrogen ion will decrease the pH. The increase of hydrogen concentration causes the pH to decrease, promoting the dissociation of dissociation of oxygen from hemoglobin, allowing the tissue to obtain enough oxygen. In the lung, when the oxygen concentration is high, binding of oxygen causes hemoglobin to release proton, here is actually hydrogen ion. It's the same lah, meaning which combine with the bicarbonate ions. The Bohr effect result in the oxygen dissociation curve shifting to the right when the carbon dioxide or hydrogen ion concentration is increased. This facilitates the increased release of oxygen when the carbon dioxide partial pressure is high, allowing the body to supply more oxygen to the tissue that need it to the most. Okay, so this diagram show about the Bohr effect. So ABC, it has a different partial pressure of carbon dioxide. So it has 2.7 kilopascal. The unit here kilopascal for the carbon dioxide and oxygen oxygen partial pressure of oxygen. A 2.7, B 5.3 kilopascal, and C 10.7 kilopascal. So A has C has a high partial pressure of carbon dioxide. So if it has a high partial pressure of carbon dioxide, the oxygen dissociation curve will shift to the right, meaning the what we call the affinity hemoglobin toward oxygen is low, compared to A. The oxygen dissociation curve is lie to the left, meaning A it has higher affinity toward oxygen. Uploading is high here compared to the loading. Okay, now we go to last part, question and answer part. Questions and answers part. Okay, number 1, which statement are true about the human myoglobin? Okay, number 1, myoglobin releases oxygen easily to muscle cell. 2, myoglobin retain its oxygen in the resting cell. 3, myoglobin only releases its oxygen when the supply of oxyhemoglobin is insufficient. 4, myoglobin has low affinity toward carbon dioxide. True, true about myoglobin. Okay, let's try. Which one is the answer? Okay, the answer is C. Number 2 and number 3. Myoglobin retain its oxygen in resting cell. 3, myoglobin only releases its oxygen when the supply of the oxyhemoglobin is insufficient. Okay, number 2. What would happen to the oxyhemoglobin dissociation curve during vigorous exercise? Vigorous exercise. A, the pH of the blood increases. B, the dissociation of the curve shift to the left. B, the formation of the carboaminohemoglobin decreases. D, the affinity of hemoglobin toward oxygen decreases. Okay, very easy this question. The answer is D. The affinity of hemoglobin toward oxygen decreases. Okay, now we check here. Number 1 for structure question. Mother dissociation curve for oxygen dissociation curve for mother's hemoglobin, fetal hemoglobin, and myoglobin are shown in the graph below. X, Y, Z. Identify X, Y, Z to mark. Okay. X, shape, hyperbolic, must be myoglobin. Y, Z. Y lie to the left, fetal hemoglobin. Z lie to the right, maternal hemoglobin. Okay, which curve shows the highest affinity for oxygen? Highest affinity for oxygen meaning the graph lie to the left. Give your reason. Curve X because it lies to the left. Y because myoglobin bind with oxygen at low partial pressure of oxygen. Give 3 factor. See, give 3 factor that cause curve Z to shift to the right. Maternal hemoglobin shift to the right. 3 mark. Okay, number 1, higher concentration of hydrogen ion. Number 2, higher partial pressure of carbon dioxide. Number 3, low partial pressure of oxygen. Okay. Alright, finish for your structure question. Now we go to part 2. Part 2 is Bo effect. Which graph shows the percentage of oxygen saturation of hemoglobin in the blood from the muscle of a person playing badminton? Muscle of person playing badminton. Bo effect. Meaning it in the graph must show the hyperbolic lah muscle kan, myoglobin. Which one is the correct answer? Okay, C. The answer is C. Okay, number 4. What is the truth about hemoglobin when blood pH increases from 7.2 to 7.4? Okay, already stated here the answer. The affinity of hemoglobin to oxygen increases. 7.2 to 7.4, meaning the oxygen dissociation curve of the graph shift to the left. Okay, number 5. Which is true about the curve if Bo effect occurs? Bo effect. So you can see here, saturation here 95%. If Bo effect occur, so lie to the left or to the right, shift to the right. Why? More oxygen can be released of hemoglobin. Answer D. Okay, now we go to essay question. Describe Bo effect which occur in the active tissue. Bo effect. Bo effect meaning the graph oxygen dissociation curve shift to the right. Affinity hemoglobin to oxygen is low. So you have to explain Bo effect in the active tissue. So active tissue, what active tissue produce that will undergo the what we call the condition of Bo effect. Okay, active tissue carry out of the fast rate of cellular respiration. Point 1. High concentration of carbon dioxide are produced. Carbon dioxide react with the water in the red blood cell or in the plasma of the cell to form carbonic acid that catalyzed by carbonic anhydrase. Carbonic acid instantly dissociate to form hydrogen ion and bicarbonate ion. Bicarbonate ion diffuse out of the red blood cell into the blood plasma. Hydrogen ion lower the pH of the blood. So, and then because of the pH of the blood is already lower, affinity of hemoglobin to oxygen in the oxyhemoglobin is reduced. And then oxyhemoglobin dissociate to form hemoglobin and oxygen. So oxygen is released, go through the active tissue for the tissues to carry out cellular respiration. So oxygen dissociation curve shift to the right. This is known as Bo effect or Bo shift. Okay, thank you very much for watching tuition for this evening. Okay, for the Muslim, cikgu ucapkan selamat berpuasa. So maybe you can get you punya what we call you punya sahur awal earlier, and then also cikgu want to ucapkan selamat menghadapi peperiksaan wish for the matriculation student that will sit for their exam. Good luck for your examination. So I hope this sharing tuition for this evening will help you to do your revision. So also for the STPM student. Okay, thank you very much. See you next week. So next week maybe we will have the tuition from sharing tuition from Cikgu Wawa. Stay tuned. Please stay tuned for our tuition, pra-U biology tuition. Okay, bye-bye. Thank you very much.